Good morning, SE student. This is Nabil Abdullah, your math teacher. Hope you're all safe. Our lesson today is about numerical sequence, exactly about arithmetic sequence. How we can recognize that a sequence is an arithmetic sequence. First of all, if we consider the sequence of numbers 2, 5, 8, 11, 14, 17, 20, and we have here a missing term, then 26, 29, 32, 35, and also we have another missing term. Also here we have 41 and 44. Now, can you predict the 8th term and the 13th term? Of course. We start counting the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, and 8th term. Can I predict what is the value of the 8th term and the value of the 13th term? If we read the numbers carefully, we notice that we have a pattern. What is this pattern? Okay, we notice that here we add from the first one to the second one 3, and then 3, then 3. We add 3 each time. I'm adding 3. If we add here 3, then the 8th term will be what? 23. And this is 26. Adding to 23, 3, it will be 26. Then 29, 32, 35, and 38, then 41 in the same pattern. So, we can predict all the 8th term and the 13th term by using the same pattern. What about the second series of numbers here? We have here the first two terms are missing, then we have here 10, 14, 18, 22, 26, and so on till 34. Then we have here a missing term, and then we have 42, 46, 50. What about the first two terms of this sequence? Can you predict what are the first two terms? Of course, we notice here that I have here 10, 14, we add 4. Then 14, 18, we add 4. Then 18, 22, we add 4. So to obtain 10, I'm adding to the preceding one, what? 4. So this term is 6. Of course, and the term that precedes 6, it will be 6 minus 4, which is equal to. So, and if we take here 34, if we add 4, it will be 38, then 4, it will be 42. So we can predict the terms by using the same pattern. What do we mean by an arithmetic sequence? Anytime you are adding the same number to each term to complete the sequence, it is called an arithmetic sequence. The number that is added to each term is called the common difference, and denoted usually by the letter D. You can denote it by any letter. The common difference can be determined by subtracting two consecutive terms. You can subtract any two terms, by the way. There is no need to subtract only the second from the first, or the first from the second. Any two consecutive terms, if we subtract it, we obtain what? The difference, the common difference. You can subtract any two terms as long as they are what? Consecutive. Hence, an arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a constant amount. The difference between, as I said before, the two consecutive terms is called the common difference. If we have the sequence 20, 24, 38, 28, 32, 36, but if they ask us to find the 50th term, here I have a problem. I'm going to determine all the preceding terms to obtain the 50th term. Do we have another way to determine this? In fact, yes. We have two ways to determine the 50th term of the sequence. As I said, the first way is to determine all the preceding terms, and which is hard to do or take us a lot of time, and we don't have too much time in this case. Or the second way is to determine the 50th term of any sequence. We would need to have an explicit formula for the sequence. I need to have un in terms of n as f of x in terms of x. Arithmetic sequence. How to prove? In fact, I gave in the preceding examples numerical examples. Here I'm going to prove how I can prove that a sequence is an arithmetic sequence in general. What do we mean by this? To prove that a sequence Vn is an arithmetic sequence, we must prove that Vn plus 1 minus Vn equal constant, which is independent of n. In the first form, we have Vn plus 1 in terms of n, Vn in terms of n, then we subtract them from each other. The answer must be independent of n, where this constant, as I said before, is usually called or denoted by d and called the common difference. As an example here, if we have the sequence Vn equal 3n minus 2, if they ask us to show that this sequence is an arithmetic sequence, what I'm going to do? We notice that they told us to prove a sequence is an arithmetic sequence, we need to determine Vn plus 1 minus Vn, but they gave us only Vn. So what I'm going to do, I'm going to replace n by n plus 1 here and here. So Vn plus 1, it will be 3 into n plus 1 minus 2, which gives us a 3n plus 1. Now I have Vn and I have Vn plus 1. When we take, by the way, we notice something here. Vn is in terms of n. Vn plus 1 is in terms of n. If we subtract Vn plus 1 minus Vn, we obtain 3n plus 1 minus 3n minus 2, which gives us at the end 3, which is constant and independent of n. I started by Vn in terms of n and Vn plus 1 in terms of n, and the answer is what? 3, which is independent of n. Another example, if we have recursive sequence here, a sequence is given in recursive form. What do we mean by this? I have u0 equal 1, un plus 1 equal un over 1 minus 3 un. And the sequence Vn, another sequence, but it is in terms of un, Vn equal 1 over un. They ask us to prove that the sequence is an arithmetic sequence. How I'm going to do this? First of all, we need, as when they ask us to determine that the sequence Vn is an arithmetic sequence, we need to determine or to find first of all Vn plus 1. So Vn plus 1 equal 1 minus 1 over un plus 1. I take this form and I replace n by n plus 1. So Vn plus 1 equal 1 over 1 minus 1 over un plus 1, and un plus 1 equal un over 1 minus 3 un. So by simplification we obtain 4 un minus 1 over un. This is what Vn plus 1. Now let's calculate the difference Vn plus 1 minus Vn. Vn plus 1 minus Vn, after calculation the answer is what? 3, which is a constant, so we can deduce that the sequence is an arithmetic sequence. Now, how to prove that a sequence is not an arithmetic sequence? In fact, to prove that a sequence is not an arithmetic sequence, there is no need to show that Vn plus 1 minus Vn is not equal to constant. In fact, it is enough to prove by calculation, by taking the numerical values, that u1 minus u0 is different from u2 minus u1. Yani the difference between two consecutive terms is not the same as the difference between another two consecutive terms. Remark, which is very important, if we prove that u1 minus u0 equal to u2 minus u1, this is not enough to deduce that un is an arithmetic sequence. To prove, as I said before, that a sequence is an arithmetic sequence, a sequence un, we must prove un plus 1 minus un equal constant. But to prove that it is not an arithmetic sequence, yes, it is enough to prove by using value of n, u1 minus u0 is not equal to u2 minus u1, as shown in the example below. If we have un defined by, given by 3 exponent n minus 2, they ask us to prove that this sequence is not an arithmetic sequence. Here what I'm going to do, we take value of n equals 0. For n equals 0, we obtain u0 equal minus 1. For n equal 1, u1 equal 1, and for n equal 2, u2 equal 7. I'm going to take the difference between the first two consecutive terms, u1 and u0, which is 2. If we take the difference between u2 and u1, the difference is 6. Here I have two consecutive terms. their difference is 2, and I have here another 2 consecutive terms, their difference is 6, then this is not an arithmetic sequence. Another example here, un is given by recurrence, and we have a recursive formula for un. Now also they ask us to show that the sequence un defined by u0 equal 1 un plus 1 equal un over 1 minus 3 un is not an arithmetic sequence. Let n equal 0, we obtain, of course I'm going to replace 0 here in this formula, so it will be u0 plus 1, which is u1, and I replace here n by 0, so this becomes u0 over 1 minus 3 u0, which is minus half. Also for n equal 1, I'm going to replace n by 1 here. We obtain u2 equal minus 1 over 3. Now, u1 minus u0, I have u1 here, minus u0, equal minus 3 over 2. And u2 minus u1 equal 1 over 6. I notice that the difference between the first 2 consecutive terms is minus 1 over 3, minus 3 over 2, and the difference between the other 2 consecutive terms is 1 over 6, so these two, they are not equal, then this is not an arithmetic sequence. General term of an arithmetic sequence. As I said in the first video, sometimes we start by labeling the terms of a sequence by 0 as u0, u1, u2. But this depends on the domain of definition, or by u1, u2, u3, or sometimes by any letter u5, v5, whatever. If we are going to use u5, I'm going to represent it by I, which can be any natural number, of course. Now, if we have v0, if we start the sequence by v0, if the first term of the sequence is v0, then the general term of this sequence is vn equal v0 plus nd. If the first term is v1, then vn equal v1 plus n minus d, and if we have vi, as I said before, it can be v5, v4, v7, even v0, then the general form is vn equal vi plus n minus I into t. As an example, let vn be an arithmetic sequence of common difference d. If they ask us to express vn in terms of n in each of the following cases, I have in the first example, in the first part of the example, v0 equal 3 and d equal 2. Here I have the first term v0, so I can use the first formula to represent the general term. In the second one, I have v1 equal minus 3 and the difference is 3 over 2. Since I have the term here v1, so I can use the second formula. We notice that in the third one I have v4, so I can use the third formula, and instead of I can put 4, yani it will be vn equal v4 plus n minus 4 times d, and I have all the information. You can see the solution of this example. Sum of the terms of an arithmetic sequence. If we have an arithmetic sequence, we have a pattern to find the sum of the terms. Now in the first place, if I have Sn equal v0 plus v1 plus vn, then we can write it in a short way that Sn equal summation from I equals 0 to n of vi, which is equal n plus 1 over 2 into 2v0 plus nd. Here I'm starting by v0. If we start by v0 till n, then the number of terms is n plus 1 terms. What do we mean by this? Why is that? If we start counting 0, 1, 2, 3, 4, 5. In fact, here I counted 6 terms. Why? Because I started by v0 or by 0. So if we start labeling the terms 0 to n, we have n plus 1 terms. For this reason here I have n plus 1, which is the number of terms. If Sn equal v1 till vn, we can write the summation as summation from I equal 1 till n of vi. In this case I have n over 2 into 2v1 plus n minus 1d, and the number of terms in this case, since we started by 1, it will be n terms.